Let's solve LeetCode problem 771, jewels and stones. This is an easy problem, but it is a good problem to show the time and space trade-off in computer algorithm design. So you're given two strings, jewels and stones, each consisting of only letters, lowercase and uppercase characters. And you want to know how many of the stones you have are also jewels. So here's an example. The jewels are lowercase a and uppercase a, and stones are this string. So this is basically a search problem. What you do is you take a stone and see if it is in the jewels. So lowercase a is in the jewels, so that's one. Uppercase a is also in jewels, so that's two. Uppercase a is in jewels, so that's three. And now you have four lowercase b characters, none of which are in the jewels. So the answer is three. In the second example, we have got jewels as only containing lowercase z and stones only containing uppercase z. None of the uppercase z's are in the jewels, so the answer is 0. So basically, what we're supposed to do is take a stone, character by character, and search in jewels whether this character exists. So it's quite a simple brute force algorithm. So let's do that. So for integer I from 0 to stones dot length I plus plus. Let's define an answer to be 0. So the character 1 is equal to stones dot character at I. So we get the character at position I from stones. Now we need to go over uh, jewels and see if character 1 exists, and if it does, we increase the answer by 1. So let's do this. If integer j going from 0 to jewels dot length j plus plus. So the other character 2, is jewels dot character at j. So we just compare if ch1 is equal to ch2. So if the character in the stones is actually also in the jewels, we increment the answer by 1. And then we break out of the one, the inner while, inner for loop. I'm sorry. So that's for inner loop and then end for outer loop. And at the end, we simply return the answer. So again, this is a very simple order m times n algorithm with order 1 extra space. So we're not using, we are not making use of extra space. Only we are using a simple local variable. So what we're doing is we're, walking over all the characters in stones. Let's call them, m characters. And for each character, we are searching if that character exists in the jewels. In the worst case, that's order of m. So it's m times n. It's a quadratic algorithm. So let's run this thing and see that it actually works. And let's submit. All right, so as you can see, it is quite simple. The reason it's running very fast is because the size of the data, if you look at it, is very small. So all of them have at most 50 characters. That's why it doesn't matter whether you have a brute force solution or an efficient solution. But let's now try to make it more efficient. So what I'm going to do is I'm going to try to reduce this searching a character from the stones inside the jewels. I'm going to reduce that to order 1. To do that, remember, this is a searching problem. So to do that, what I'm going to do is I'm going to declare a Boolean lookup table. So Boolean lookup table array is equal to new Boolean. So the maximum number of letters that we can have in jewels is it goes up to z. So I'm going to do z plus 1. Initially, all of them are false. So what I'm going to do is now walk over the jewels. So integer I going from 0 to jewels dot length I plus plus. Let me take the character from the jewel. So jewels dot character at I. So I took the character. Now I'm going to use this character as an index into this lookup table. So This is true. So I'm basically what I'm doing is I'm creating a lookup table that consists of z plus 1. Z is 117 if I'm not mistaken. So it has 118 cells in this array. So all of them are false in the beginning, meaning that none of the characters exist in the jewels. But if the character exists in the jewels, I'm just marking it as true. So this lookup table is going to now help me to determine whether this character in the stones is also in the jewels. So all I have to do now is say if lookup table ch1. If this is true, then I'm going to increment the answer. So again, I'm using a lookup table to reduce the searching time into order 1. So I'm using the ch1 from stones and using that as an index into the lookup table, which I have already created at the beginning, right? So this lookup table is basically marking those characters that are in the jewel. So I'm saying if the character in the stone is also in the jewels, if this is true, then increment the answer. Again, by using extra space, we are making the problem, converting the problem into n plus m, n being the size of the jewels, m being the size of the stone. So this is now order n plus order m. So the previous algorithm was a quadratic algorithm, m times n. This is a n times m plus n algorithm. So it is linear on the size of the length of the strings. So as you can see, this is much better. There is another trick that I would like to show you. So here we are using a Boolean array. So we have to do an if statement. So if the lookup table, if the character is in the lookup table, then increment the answer. These if statements are not good in the sense that if it is possible to avoid writing an if statement in your code, it is preferable that you avoid if statements. I don't want to go into the details of why this is the case. You should understand it when you take your computer architecture course. If statements create branching points in your code, and that kind of makes it difficult for the architecture to determine which instruction to execute next, right? Of course, the architecture has optimization methods, or the compilers, when they generate the code, they make it possible to execute this efficiently. But from a programming perspective, avoiding these kinds of if statements is something that you should avoid if possible, of course. So what I'm going to do is, instead of making this a Boolean lookup table, I'm going to make it an integer lookup table. So what this makes is when I allocate the lookup table, everything is 0. So instead of marking it as true, I'm going to mark it with 1. So now all I can do is I can do this. I can say answer plus is equal to lookup table ch1. So remember, if ch1 is also in the jewels, the lookup table will contain 1. So I'm going to increment answer by 1. If ch1 is not in the jewels, lookup table's value would be 0, because when I allocate this lookup table integer array, all the values are 0. So I'm not incrementing. I'm incrementing it by 0, meaning that I'm not incrementing it. So I just got rid of I've just gotten rid of the if statement, as you can see, and that's the preferred code. That's the ultimate preferred code. This is a linear time algorithm. This is a m plus m. So let me write it that way. So it's m plus n algorithm. This is still order 1 extra space, in the sense that the amount of space that you are allocating is constant, because z is 117, so this is 118. So this lookup table only has 118 cells. That is a constant, so it is still considered order 1 extra space. But still, we are using extra space. So in that sense, by using extra space, a lookup table, we have reduced the running time of our algorithm from m times n into m plus n. So that's the time-space trade-off that I'm always talking about. If you have any questions, just leave a comment in the comment section, and I will try to answer them.